Hello, Miss Hanley here. Today we're going to talk about inverse linear functions, and we want to be able to find and graph the inverse of a relation and find the inverse of a function when it's given as an equation. So there's a few different ways to look at relations. Remember, we can have a point, a table, or a graph. So I'm going to start with points. Let's say we have a set of points, and I'm just going to make up some numbers. We have the points 0, 5, negative 7, 4, and 6, 6. So that would be my current relation. If I want to find the inverse, your domain and your range are swapping. So domain is your x's, and your range is your y's. So my inverse set would be, instead of 0, 5, 5, 0. Instead of negative 7, 4, 4, negative 7. And if we have 6, 6, that's just going to stay the same, since our domain and our range in that case are identical. Same idea for a table of values. Let's use these same points here, 0, 5, negative 7, 4, 6, 6. If this is my relation right now, I can go and make the inverse by switching my x and my y. So now my point would become 5, 0, 4, negative 7, and again, 6, 6 isn't going to budge. Lastly, from a graph, you want to pull the points off of your graph. So here I have the point 1, 2, 3, 4, 5, negative 1. And you might have a line, you might not have a line if you're just given a relation. So I don't want to think about it as a line right now, but just as a point. This point here is 0, 3. Well, for your inverse set of points, again, when we talk about an inverse, we use f inverse of x if we're talking about a function. Since it's a line, this is a function, passes my vertical line test. The points that would fall in this inverse function are 3, 0, and negative 1, 5. So by graphing those two, we could find our inverse function. 3, 0 would put me on the x-axis, and negative 1, positive 5 would put me up there. Connect your 2 points, and that is your new line. One thing to mention here is that if you are dealing with lines, as we have been this whole entire time, their slopes, the slopes of inverse functions, are reciprocals. So if we find the slope of my first function, we can find our rise over run. We went down 1, 2, 3, 4. And to the right, 1, 2, 3, 4, 5. So there my slope was negative 4 over 5. If we graphed the second one correctly, our slope should be 5 over negative 4. So if I check this out here, we go down 1, 2, 3, 4, 5. So a negative 5. And to the right, positive 4. Remember, you can attach the negative to either, so that is the reciprocal. So this is my inverse slope. This was my original slope, for negative 4 over 5. They are reciprocals of each other when you're dealing with inverse linear functions. Finally, the trickiest part is to actually find the equation of an inverse. And I've written out the steps on the right, and we're going to walk through one of these together. Your first step is if you're given a function, f of x equals negative 1/3 x plus 2, that's our function, you want to change from function notation into just regular notation. So from f of x, we're going to replace that with y. So all I want to do is take out my f of x and replace it with a y. Now we need to switch our domain and our range, just like we did with the points. So our y becomes an x, and our x becomes a y. Third step, you want to solve this for slope-intercept form for y. So in order to do that, I need to move the 2, the plus 2 at the end. And by doing that, I'm going to subtract. So we end up with x minus 2 equals negative 1/3 y. I want to get rid of the negative 1/3 because I need just y equals. So I'm going to multiply all the way through by a reciprocal, 3 over negative 1. That creates negative 3x plus 6 on the left, and it's equal to positive y on the right. So negative 1/3 times negative 3, those cancel each other out and just become 1y. Our fourth step is to replace the y with f inverse. And by doing that, you've shown this is your inverse function, negative 3x plus 6. Again, you should notice that your slopes here, negative 1/3 and negative 3, those are reciprocals of each other. From there, you can graph anything you want, inverses or the regular equations, and you should be all set.